Okay, problem solving. So this content or this video here consists of 4 examples, 4 problem solvings, okay? From basic to medium toughness, okay? So example 1. Now find the power transmitted by a belt running over a pulley of 600 millimeter diameter at a speed of 200 revolutions per minute. The coefficient of friction between the belt and the pulley is 0.2, and the angle of lap or wrap is 160 degrees. So remember, this must be converted to radians if you were to use the belt tension ratio. And maximum tension in the belt is 2,500 Newton. So they say maximum tension means the tight set tension, okay? So you have the maximum tension T1 or the tight set tension as 2,500 Newton. And then they have given us the diameter of the pulley is 600 millimeter, which is also equals to 0.6 meter. So first of all, we find the angular speed. So by using 2 pi n over 60. Now 2 pi converts 1 revolution. So 1 revolution is equal to 2 pi. And then minutes to seconds. So you have to, that is why you have to divide it by 60. So 2 pi 200 over 60. So you got your angular speed of this pulley, angular speed, as 20.94 radians per second. So then, okay, after getting the angular speed, now we can actually find the belt speed by taking r omega. R is the radius of the pulley. So this is given in diameter. So half of it is 0.3. So with the speed of 20.94, so you have your tangential speed or your belt speed as 6.28 meter per second, which is less than 10 meter per second. So that is why in this problem here, we don't take TC into account. We don't take TC into account. So angle of lap. So they have given us the angle of lap of 160, remember, divided by 180 times pi to convert it to radian, or you can use 360 and 2 pi here. So you will get the same answer of 2.79 radians. Then after that, we apply belt tension ratio. Now this question here, they didn't say is a flat belt, or circular belt, or V belt. So most of the time, in this type of cases, okay, we consider it as a flat belt. And then we have proven that, okay, we are not taking the TC into account. So that is why we are using the simplest form, okay, the formula, the simplest formula for belt tension ratio to calculate the T2. Why do we need T2? Because we need to calculate the power transmitted. So remember, power transmitted formula we have T1 minus T2 times V times N, yeah? So the power formula is this. So we have our T2 now. So substitute T1, T2, V, the velocity of the belt, with only one belt. So you got 7884.1 watts. Okay, that's first example. Now we move to second example. Now, a casting weighing 9 kilonewton, 9 kilonewton. The weight is 9 kilonewton, is in Newton, not in kg, hangs freely from a rope which makes 2.5 turns, okay, round a drum of 300 millimeter diameter, revolving at 20 revolutions per minute. Now, the other end of the rope is pulled by a man. Now, the coefficient of friction is 0.25. Find the force required by the man and the power to raise the casting. Okay, so I have a simple diagram here. So this drum here, this is the drum or the pulley, okay, has rotated 2.5 revolution for you to raise the mass of 9 kilonewton. So we have slack side tension here, the T2, and then the tight side That means on the wave side, you have tight side tension T1. So these are the given data. So belt speed, first thing we go for belt speed, R omega, where R is the radius and omega is the angular speed. Now this 2.094, if I'm not mistaken, okay, the order is mixed up. Okay, so the omega, I will show you the omega, how you find this value afterward. Yeah, so the omega is 2.094 multiplied by the radius of the drum. So the diameter of the drum is 300 mm. So into meter is 0.3 and then divide by 2, so you have 0.15 times the omega. So you find the omega by taking 2 pi over 60 times this 20. So you should be getting 2.094. Okay, so that is the velocity of the belt. So 0.3141, which is also less than 10 meters per second. So regarding the angle of lap or the angle of wrap, they have said, okay, the belt or the rope, but here you better use a belt. I think I have to change this to belt, which makes 2.5 turns. That means it complete 1 cycle, 2 cycle and a half. Okay, so 1 cycle is 360. 2 cycle is how much? 360, 720. Then 2.5, so you have 900 degree. So convert these to radians, it should be equivalent to 5 pi radians. 5 pi radians. Okay, this is a belt. Okay, better change this to belt. Okay, so D1 is 300 millimeter. That is the diameter of the drum. That is the speed. So that is why here you got 2.094. Yeah. Okay, 2.094. The order, I have left out the order of these two here. Okay, so you can find out the speed, substitute here to find out the tangential velocity. So by applying the belt tension ratio of T1 over T2 equals to exponential mu theta. So to find out the T2, so you have 177.33 Newton. So the question asks us to find the power. Okay, so we can use the simple definition of power for belt and pulley drive. T1, T2, velocity of belt and number of belts. Okay, so you got 2771.2 watts. Okay, then next example. Example 3 is getting harder and harder. Now, 2 pulleys, one of it is 450 millimeter diameter and the other one is 200 millimeter diameter, are on parallel shafts. Parallel shaft. That means you have one shaft and another shaft is just sitting nearby to each other, and then it is parallel to each other. And then they are 1.95 meter apart from each other. So you measure from the center of one shaft to the center of the next shaft. So you've got this distance to center distance of 1.95 meter. And they are connected by cross belt. Okay, find the length of the belt required and the angle of contact between the belt and each pulley. Now, what power can be transmitted by the belt when the larger pulley rotates at 200 revolutions per minute? And if the maximum permissible tension, that is T1, tight side tension, is 1 kilonewton and the coefficient of friction is 0.25, Pulley, pulley. Okay, so this is the sample of a cross belt. So they have given us the diameter of this 0.2. So you compare. So this should be the smaller, this should be the larger. Okay, so when you draw the diagram, this should be the smaller one and this should be the larger one. Okay, so you have the theta here as the angle of wrap. So the center to center distance x is given 1.95 meter. So these are the given data. So your T1 is 1 kilonewton, your coefficient of friction is 0.25, the speed is 200 revolutions per minute. So the first thing is they ask us to find the length of the belt. The first part is to find length of belt. Length of belt. So this is the formula that we use. Remember, this is for cross belt. So that is why here is plus. If it is open, then this part here is minus. Okay. So by putting in your R1 and R2, it can be in meter or millimeter. You can use in terms of millimeter or in meters. Okay. So the total length of the belt in this question is 4.98 meter. Then the next thing is to calculate this angle alpha here so that we can calculate the angle of wrap. So to find alpha from the earlier definition or from the earlier proving formulas, we got alpha is equals to this. Okay, so putting in your R1, R2 and the center to center distance here, which is 1.95 meter, so be able to find out the alpha, this angle here. So to find out the angle of wrap, okay, so that is theta in this diagram. So you can take 360 degree minus of 160.81. So you got 199.19. Then you can at the same time convert these to radians straight away. Okay, divide by 180 times pi. So you got this in radians, in the form of radians. Then the next part, okay, to find out the speed so that you can find out the velocity of the belt. Okay, so they have given us the speed as 200 revolutions per minute. So omega 1 is 20.94 radians per second. Okay, then for belt speed, which is the tangential speed, radius and speed. So the radius and the speed. So this is omega 1. We are looking at omega 1. So the 200 RPM they have given, which they have given, they say that is the larger pulley. That is the larger pulley, which is at 200 revolutions per minute. So larger pulley is this. So make sure you use this R here is with respect to this diameter. Divide by 2, so you get 0.225. Okay, so this one is the speed of this. So that is why we must use R1 when you use omega 1. So if you use R2, this must be omega 2. So this will be the belt speed, 4.71, and it is less than 10 meters per second. So in these four problems, these four examples here, will be based on, okay, not taking TC into account. Okay, not taking TC into account. The next lesson, we will be solving problem taking more difficult questions. Okay, so you just hang on and be patient. Okay, so this is the belt speed. So then we need to find tension on the slack side by applying your belt tension ratio here. Okay, the same thing. So your exponential mu theta should be on top here, yeah. So it is 418.95 Newton, which is your T2. Okay. So then after that, of course, you can find out the T1, T2, V, and N. So that is 27365 watts. That's example 3. Then we move to the fourth example. So I hope it won't be too much because of 4 examples in one slide or in one video. Sorry for that. The fourth example, a shaft rotating at 200 revolutions per minute drives another shaft at 300 revolutions per minute. So we have given the speed for both, yeah? Drives another. So that means this is the driver speed and this is the driven speed. Okay? Because it said this is used to drive this. Okay? And transmit 6 kilowatt through a belt. So this is the power transmission. Now the belt is 100 mm wide, so area is taken into account here. 100 mm wide and 10 mm thick. Okay, the distance between the shaft is 4 meters. Now the smaller pulley is 0.5 meter in diameter, but they didn't give us the diameter of the larger pulley. You take note, They have only given us the diameter of the smaller pulley, but not the diameter of the larger pulley. That means if let's say we want to use the 200 RPM or the 300 RPM, that means we must have both the diameters. Now calculate the stress in the shaft. So that is why they have given us the area for us to calculate the stress. So based on first part is an open belt drive. The second part is based on a cross belt drive. So you have to compare, okay? You have to compare the amount of stress that is developed within the belt, okay? So first is the open belt drive. So you have pulley 1 and pulley 2. Okay, so speed of pulley 1 is 200. As you compare, one is 200, the other one is 300. So the speed here is lower, one is lower. So definitely the diameter will be larger than the second one because speed and diameter are opposite. Okay, so since when you compare these two speeds, this is smaller, this is higher, this is lower, and this is higher. So definitely the diameter for this will be larger and this will be smaller. So the power given is 6 kilowatt, and then they have given us the dimensions of the belt as well, 100 mm width and 10 mm thickness. The center to center distance they have given is 4 meter. The diameter of the smaller pulley is 0.5 meter. So what we need to do is try find out the diameter of the larger pulley. So by applying what we have learned, D1 over D2, if you write here as D1 over D2, then this side here should be N2 over N1. Remember, it's always opposite. So if you write D2 over D1, then N1 over N2. So what we want is D1. So D1 is the subject. So putting in D2 and the speed, so you should be able to find out the diameter of the larger pulley, which should be 750 millimeter. So then this is open. So open belt drive, the angle of flap straight away, we can use this to find out the theta, which is 176.42 degree. Okay, to convert it to radians, so you have 3.08 radians. Then the next thing is the speed. Okay, so N1 is 200. So you got omega 1 is 20.94. Okay, 2 pi and 60 is standard already. Okay, by converting revolutions per minute to radians per second. Unless the given speed is revolutions per second, RPS, then you don't divide by 60. So the belt speed is 7.85. You can double check. Okay, you can double check, even though you can double check by taking R2 omega 2. Now what we have taken is R1 and omega 1. Okay, the R1 and the omega 1. So the tangential speed or the belt speed is 7.85. It's still less than 10. So that is why this example also we are not taking TC into account. So the belt tension, based on belt tension, okay, we have this. So what is T1? They have not given us any T1 or T2 value, okay? So you make use of this equation, work it out, okay? You get 2.52. That is the ratio of T1 to T2. So this section later on, you can say T1 is equals to 2.52 T2, okay? Then you can put into T1 here, which is 2.52. You see, T1 over T2 is equals to 2.5. So T1 will be 2.52 T2. So put it here so that you can find out your T2 because they have given us the power, 6 kilowatt. So with these two equations, if let's say the P, the power, the coefficient of friction and the angle of lap is given, then definitely we will be able to work out T1 and T2 by simultaneous equation, okay? So then you can find out your T1. This should be 2.52. Something wrong here. Okay, 2.52. Okay, you can double check this later on. Should be 2.52 here. It's not 2.61. So based on this, we know area is width times thickness. So you got the area. And then we know that stress equals to force divided by area. Stress is equal to force divided by area. So the force that we consider should be the greatest among the T1 and the T2. Definitely T1 is the one we choose because it's the maximum tension or the tight side tension. So divided by its area. So we got the stress developed is 1.267 Newton per millimeter square. That is only for the open belt. Now for the cross belt. So this is the cross belt. So first thing is work out the angle of lap. Okay, angle of wrap. So I think I have put this the other way around again. This should be alpha and this should be theta. Sorry, mistake. Okay, I keep on having mistake lately. Okay, so this should be your alpha. This should be your theta. So R1 and R2, so you got 162.02. That should be here. So to find this angle here, you should take 360 minus this angle. So you will get your angle of flap, you see. Okay, 3.44 radians. Based on this value, yeah, you find your angle of flap based on this value, 3.44 radians. So a little bit confusing here with the symbols. So the belt tension ratio, you can work it out here. Remember, mu, theta. Theta must be in radians. So you can work out T1 over T2 equals to 2.81. So by putting in 2.81 T2, by replacing T1 here, you will have your T2 and your T1 as well. T2 and T1. Okay? So based on that, work out your stress. Work out the stress. The force, maximum force among this is this, the tight side. So you got the stress as 1.19 Newton per millimeter square. Then you start comparing which one actually will develop more stress. Okay, which one will actually develop a greater stress. So this is 1.267, but then that problem is there is an error in that part there. So you can compare these two values and then you can put a comment. Okay, the stress is developed, which one is greater, open belt or cross belt. Okay, thank you very much for your time. And then everyone, please remember to stay safe. Yeah, thank you very much. See you next lesson. Thank you. Bye bye.